Hi, my name is Justine Harkness, and in this video we'll look at how to design synthesis pathways for substitution reactions starting with alcohol substrates. The OH group itself is not a good leaving group because when OH leaves, it would leave as OH minus or hydroxide, which is a strong base. Thus, it's not stable in solution and will not function as a good leaving group. So in order to do substitution reactions with alcohol substrates, we must first transform that OH group into a better leaving group. For Sn1 reactions, which we'll see with either secondary or tertiary substrates, because we use polar protic solvents in these reactions, to turn OH into a better leaving group, we just add acid to the reaction conditions. So if I am starting with some sort of secondary alcohol here, note that this OH group, again, as our leaving group, would be OH minus, which is not a good leaving group. But if I were to add acid to the reaction conditions, just a little bit of H+, that would allow me to protonate that OH group. So when this whole thing leaves, it will leave instead not as hydroxide, but as water, which is a good leaving group. The really nice thing about using acid is if I wanted to turn an alcohol into a halide, I could just use an acid halide, something like HBr, where the proton here would be used to protonate the OH group, and then the halogen, remember this would be H plus Br minus when it dissociates in solution, would serve as the nucleophile for the substitution reaction. Now, if I instead am starting with either a methyl or a primary substrate, we'll use an Sn2 pathway. Since Sn2 reactions require polar aprotic solvents, we cannot use acid. So instead, we have to transform that OH group into a better leaving group through the use of tosylate and mesylate. And let's take a look at how that works. Now we're looking at both tosyl and mesyl. So we'll start with tosyl groups. In these reactions, we'll start with an alcohol. That OH is a nucleophile, so it can attack the sulfur and kick off chlorine as the leaving group. Now, in this reaction, we would be producing protons and we would be producing chlorine. So we would produce as a product hydrochloric acid. That pyridine is a base, so it will be used to neutralize the hydrochloric acid produced during these reactions. And as our product, we now have our tosyl group added, and this entire group now would be the leaving group for subsequent reactions. If we wanted to, instead of using a tosyl group, add a mesyl group, it would be a very similar reaction. That OH group would act as the nucleophile, displacing chlorine. It would be producing both hydrogen ions and chloride, so producing HCl. We'd have our base, our pyridine, to neutralize that HCl. And in our final product, we would have this entire group as the leaving group. So tosyl and mesyl groups can be used to transform OH into a good leaving group. Now let's take a look at some practice questions. Now this question asks us to draw out the synthesis to form the following products, starting specifically with an alcohol substrate. So the first thing we need to do is to choose our substrate. So to make this product where we have bromine added, we would just start by replacing that bromine with an alcohol to get our initial substrate. Notice that what we have here is a tertiary alcohol, which indicates that the substitution reaction that we'll use will follow an Sn1 mechanism. So to do this, we need to use acid to protonate that OH. So what we'll add is hydrobromic acid. The H plus will protonate, and then the bromide will later attack our carbocation intermediate, giving us our substituted product. So let's draw out the steps here. So the first step would be the protonation of our alcohol. Notice that now we have water as a leaving group. So whenever the water leaves, we would be getting a carbocation intermediate. Now that we have our carbocation intermediate, the bromine that we have made from bromide will attack our carbocation, and this will give us our final substituted product where we have replaced that alcohol group with a bromine. Now let's take a look at example B. Now in B, we are adding a fluorine in place of an alcohol. So our starting substrate would just have an alcohol group instead of the fluorine. Notice what we have here is a primary alcohol, which indicates that this will follow an Sn2 pathway. So we first need to convert that OH into a better leaving group, and we can do that with the addition of a Tousle group. So in this reaction, that OH is our nucleophile, specifically the oxygen, and it will attack the sulfur and kick off chloride as our leaving group. And of course, our pyridine will be neutralizing the hydrochloric acid produced as a product. So now we have a good leaving group here. So we can use this in a subsequent Sn2 reaction. So because this is going to follow an Sn2 pathway, we need to choose our nucleophile. Since we are substituting in fluorine, we could use fluoride as our nucleophile, and we can do any sort of polar aprotic solvent like acetone. So that fluorine, that fluoride, is going to come in and attack and kick off our leaving group, forming our final substituted product where we have fluorine now in place of that OH group. Let's look at one final example. In this case, we are needing to start with an alcohol, and here we are making a thiol. So to find our starting point, we'll just replace that SH group with an OH group. Notice again, we have a primary alcohol. So this will also follow an Sn2 pathway for substitution. We'll first convert that OH group into a better leaving group, here through the use of a methyl group. So just like before, that oxygen of our OH group is going to act as a nucleophile, attack the sulfur, and kick off chlorine. And this will give us our substituted product where now we have a good leaving group. We can use this for another substitution reaction. So since we are adding that SH group, we would use SH minus as our nucleophile. And then for our solvent, we can use any sort of polar aprotic solvent, perhaps DMSO this time. So our SH minus nucleophile is going to come in and attack, kicking off our leaving group, and then we would get our final thiol product. So now you should feel more comfortable starting with alcohols and undergoing substitution reactions, either via Sn1 or Sn2 pathways.